Hello folks, welcome to my video and let's start using Wireshark. The Wireshark is an extremely powerful network capture tool. It is something that people sometimes stay away from just because we tend to avoid something we don't have experience with. But it is extremely simple, it's very easy to sort out specific troubleshooting steps if you know what you are doing. The complexity lies in the different functionality that it provides. But if you are trying to solve a simple task, the actual steps you need to do are also quite simple. So today we are going to review the same scenario that I had in previous videos, which means attempt to connect with the remote desktop which fails or doesn't work because of the firewall. And I want to show you how can you find the information and understand what's happening using Wireshark and TCP packet headers. So in order to understand this better, you should either watch my previous videos which explain the different OSI models and basic functionality. This is where we discussed commands such as netstat, nslookup, ping, and testnet connection. Today, I'm going to build upon that, and the concepts are pretty simple. We are starting with the fact that we are trying to troubleshoot TCP connections. So let's draw this on the picture before we proceed. So there is a client. The client is going to be our domain controller computer, which connects to a server. The connection is done using remote desktop. And RDS service starts with a random port. So this is dynamic TCP. And it ends up at the port 3389, unless you manage to reconfigure this. And in our case, what we do, we create a firewall rule which blocks this connection. And last time we discussed that we can try to telnet, or we can use test. So testnet connection, I think, is a commandlet which is a part of the PowerShell. It's this one, testnet connection minus computer name minus port name. So that's what you can use to test it, and you would get an error. But now we are curious about more troubleshooting functionality that could actually show us what's wrong on the actual capture level. So the way we do it, we are going to run Wireshark here, and it will have filters which only look at the computer which we target, and we are going to run Wireshark on the target computer, which also has filters only targeting these computers. So the filters will be what? The IP addresses, so it's 172.168.0.1 and 172.168.0.2, and it will be ports. So we don't know the source port, but we know that the destination port is 3389. And at this point, we decided that we have already tested and we know that the test connection fails. And we also tried netstat, and we confirmed that on port 3389, there is the terminal service. There is one trick which makes it somewhat easier to find which process is taking a port if you don't want to dump netstat into the file and open and search it. One of my viewers, Chris Evans, showed me a command which is useful. This is a command which I can show you right now in PowerShell. The command itself is get net TCP connection. And you can use this command with minus local port, which will limit you to the port. So basically, if you run this command like this, in this case, it goes into the $connection variable. If I check my variable $connection, you'll see that it did capture something on port 3389. And the only thing left to do to figure out what is on this port is to get this connection variable and check the property. So you type the dot and then property owning process. And that gives you the process ID. So in order to understand what I did, you need to know PowerShell a bit, but basically we have run the command. You can run it without $connection equals, but when I do this, I basically write the result of the command into this variable. And then I check the property of this variable called owning process, which gives me process ID. So now if I go to the task manager, I'll find the process ID 436, and this will show me which process is taking this port. Unfortunately, most of Windows services are not separate applications. They're actually Windows services. So if you see these processes called svchost.exe, they are system wrappers or system processes, and you cannot really tell them apart. So it could be my remote desktop taking this port, or it could be any other service. The cheat method to test it, because you could of course run netstat and it would show you the service. But if you want to figure out what is the process, you would want to go to the properties of the columns that you have in your task manager and enable command line, because here you can see which service is being executed. In our case, you see it's svchost.exe, but then it shows -k and term services. So this is a terminal service, which is a remote desktop service. This is a cheating method. Basically, you're not supposed to look there most of the time. I mean, nobody checks it often, but this, how can you pick into svchost? Like for comparison, if you look at other svchost processes, you can see this is RPC service, this is DCOM service, this is Windows 32 time, this event viewer, this is time broker. So basically, theoretically, you're not supposed to know which service it is, but if you look at the command line, you'll find it. That was a bit of an extra, just to explain to you how can you grab specific process directly without going through the whole output. And maybe it helps some of you who study PowerShell or who are interested what is svchost. Now let's return to the topic of the video. So we know at this moment that the connection doesn't work. And because we have set it up this way, we know that it's a firewall, but if it was a real environment, we wouldn't know what's going on. So what do we want to figure out? We want to look at the traffic and see how it behaves. Last time in the last video, I explained the difference between TCP and UDP. So if it was just UDP and you were sending data, you wouldn't check anything. It would just try to go through, and if it ever fails, it fails. But because it is TCP, it sends the request, and then it expects an answer that the request went through. And then it will follow up saying, okay, I have got your answer, we can work. So these three packets, TCP packets, are different. They have specific flags. The flag for the initial packet is SYN. And then you get SYN ECK, and in the end you get ECK. So it's synchronization and acknowledgement. So we can see all these three packets with Wireshark, because Wireshark is a tool which allows you to actually capture packets and see them. So today I'm going to demonstrate you how to do this with just a few considerations. And also I'm going to share some of my, let's say, wisdom on how you can improve the Wireshark capture. Hopefully it's going to be useful for you. So there are two computers at the moment, DC01 and EX01. Computer with domain controller and computer with Exchange. On the Exchange server, I'm going to open the firewall properties and block the incoming TCP connection for RDP. So it's port 3389. It's this rule which is normally allowed user mode TCP in. So I'm blocking this connection, right? So now let's test that it actually blocked the connectivity. Let's try to connect, and we'll see that the operation is hanging. It doesn't go through. So at this moment, we want to start using Wireshark. You can grab it on the website wireshark.org, where you can download different versions of the product. We are using the most recent one. And when you install it, you will also want to install NCAP driver, which is basically a network driver which allows the capture. So let's start the Wireshark on both computers. Okay, so now we have a field called capture filter. If you just select an Ethernet card that you want to capture, in my case it's Ethernet 0, which I can verify if I try ipconfig, which has this IP address, and this is the network adapter which you see as well as Ethernet 0. There are a few other connections which I do not use, because they are most likely stuck in the virtual settings or in registry But right now I'm curious about the standard Ethernet adapter. I have the same adapter on the second machine. If you have multiple cards, you need to find out which one do you need. And if I start capturing now, it's going to capture everything. It's going to look like this. And I will be unable to make anything useful out from all of this. So let's stop it. So the way you would like to go about it is the following. You would want to specify a set of rules which define what do you capture. We know that in our case, we are going to go and work with the computer 172.168.0.2. So we want to have host 172.168.0.2. If you only wanted to go to a specific host and not back, you would specify DST host, so it's destination. Alternatively, it will be SRC host. But in our case, I want to see traffic going back and forth, so I will just use the host value. So this is enough to limit traffic to only what's happening from this computer to the target computer. I also know that we want to go to specific port, 3389. So I'm going to say end and type TCP port 3389. Also, what I like to do if I have multiple rules like this, I like to wrap them separately in brackets. This way it's much easier to read them as separate rules, and end is between. It could be or, in that case it would capture either or, but this is a typical logical expression. So brackets are not important, but they're useful for reading. And if I would start capturing now, it would be already useful for us, we could do the job. There are a few adjustments I would like to do first. So if you go to capture options, you will see that for your adapter, there are quite a few different settings. One of them is a value called snap plan. So it's how much of the packet do we capture. In our specific reason, we only want to know the SYN and ACK flags, so we don't need to know what's inside. And it makes sense to make this much shorter. I would say if you make it 128 bytes, that's more than enough to capture even SMB packets. And for standard TCP SYN ACK, it's more than enough, because those are like 60 bytes or something. This way you will reduce the total size of your capture. Another setting you want to set up is your output file. Because if you capture to the memory or to the temporary file, you do not have control of how much space do you use. You would rather browse and select, let's say, a specific disk, and then create a file. Let's go to my downloads folder. Here, TCP capture. Okay. You can also make this file as a single huge file, which will probably be hard to read. Or you can select an option to create new files automatically, let's say, after 100 megabytes. This way, you'll have multiple files, 100 megabytes each. And you shouldn't worry about finding your capture later, because if you feed one of them to Wireshark as a capture, it will connect all of them together as a single capture. So as long as you keep them as separate files, it helps you to manage them. But it's not necessary. I don't need it now. Also, you can go to options and stop the capture of specific size. There are a few other quality of life things. For example, you can automatically resolve network names and transport names here. That will allow the display to show the names instead of IP addresses. I do not use it now for a simple reason that I already know my IP address. And there are a few other drawbacks. Let me explain why these are not the best sometimes. So you will want to resolve MAC addresses to get IP addresses for sure. But if it comes to DNS, you'll actually have to go to DNS and capture the name. And this may be wrong at the time of the capture, because after you come back, you could have different DNS, bring up the trace, and you would have a different information. Also, these values are cached, so if they change during the capture, you may not have them displayed correctly. And finally, this can create additional traffic to DNS server. But if it's not an issue for you, you can use these values. I'm not going to uncheck them now because I don't need them. But keep in mind that these options exist. So now we have settings set up here. We are saving into the file. And we also select the PCAP format. I think PCAP-NG has a bit more advanced, let's say, tracked options. But right now, for us, it's enough to have PCAP because we are not trying to get into very advanced stuff. If you would be interested in pickup PNG, you probably wouldn't need this video. Let's set the same on the second computer. So we'll have the output file. I'm going to dump it in an E drive, TCP capture. I'm going to use pcap, and I'm going to capture only 128 byte size of frames. That should be good to go. One more thing that I need to do is to set up a filter. So let's select the adapter. Unfortunately, it kind of drops the filter. Let's use our filter host 172.168.0.2 and TCP port 3389. And the target computer, we could also use host, but I'll just use TCP port 3389. If there were more computers connecting, we could switch it to a specific source host or specific host only, but this should be enough. So if we start this capture now, nothing should be happening, because I'm not trying to connect to the port on that computer using my remote desktop. Now, when I try to do that, let's see what happens. So you see there is TCP, and it sends SYN in the flag. SYN means that it tries to synchronize, right? So that's the beginning of the SYN-ACK sequence. So these flags are very visible. And then you can see there are specific black lines which are called TCP retransmission. So what actually happens whenever SYN doesn't go through, so if this SYN doesn't get a returned answer, we'll try to send it again and again. And this SYN would be marked as retransmission. So this is something I briefly explained in the last video, but if you see these retransmissions, means that something is not delivered and we try to get again and again. You will see why as well, because once this fails, it does it a couple of times and fails again. What we can see on the target capture here is that we keep receiving the same packets. You see, they're going through. So you can confirm this way that there is nothing wrong in the network between the two computers. If there was a problem in between, you wouldn't get these packets on the secondary computer, on the target. If the network wouldn't work, for example, it would be lost somewhere. But this way we can say that the packets go through and this packet receives it. At this point, there are only two things that could be wrong. Either your software misbehaves or the firewall doesn't work. So this would be already enough to find out and rule out the firewall. Now let me show you what would be the difference if we do enable the firewall rollback. By allowing the connection, the SYN should be followed by ACK. And now you can see this is SYN, and then we get SYN-ACK back. You see it goes from port 3389 back to the same port that we started with. And you can see there is this huge 65355 port, which is a dynamic port. So the connection started, in our case, from port 65535. This is a dynamic TCP. Sorry, 65355. But you get the gist of it. So by this simple setup, simply configuring the capture filter using host, IP, and TCP port number, we can easily find out what's happening between two computers. And here on the target computer, you can see the same. That the connection got SYN-ACK, and then you get ACK. A very quick intervention. If you do not understand which SYN-ACK came from, by double-clicking the packet and expanding these options, you can see a specific field called SYN-ACK analysis, which tells you that there is an ACK to a segment, a specific frame, 15. So you should see the number in the first column, 15, and that would be the SYN that you get the ACK for. This is just something I didn't mention in the video at first, but it seems to be important if you have a lot of connections and you need to find out which ones do go through and which ones don't. So these three packets, TCP from dynamic port to 3389, which is called SYN, and then reply from 3389 to 65355, which is dynamic back, syn ACK, and then finally ACK going back from dynamic port to 3389 depicts a successful TCP handshake. And now the application can work. For example, if I do connect, it will work. Also, if the connection is cancelled like this, you'll notice there is a specific flag called RST. So RST is when connection gets aborted. Otherwise, if it would finish normally, this flag would be fin. So what we learned today is that the setup is pretty simple. There are a few things to take into account, such as packet length that you capture, the interface you select, the file, so you would control how much space you take on the drive and where, and the filters. For the specific filters, you will want to open the filter documentation on Wireshark site. If you go to get help and documentation, you can find everything you need. You can also find specific user guide, which will tell you exactly what I told you in a lot more details. But this is something you may want to check if you are curious about specific menus. But that should be enough. And finally, one thing I wanted to mention, which is not critical for this kind of troubleshooting, but might be helpful. If you are sharing the capture, you may want to know when the problem happened in the past. And this time doesn't make much sense. It's actually a number of seconds since you started the capture. But the capture remembers the time of the computer when you started it. So if you go to view, time display format, and time of day, you'll see real time that is displayed in the time column, which will be very helpful if you try to compare the errors in this capture with the errors in your log file of some application. Hopefully, this was a useful information. If you want to discuss specific use cases or if you want to learn more about Wireshark, feel free to post in the comments. This was the most basic application, but it shows you how easily you can depict the problem and how easily you can detect it. You just find these black lines for transmission, and if there is no problem in the network connection, you also verify that the packets get delivered. Otherwise, you know it immediately. And finally, to know the firewall problem, you'll just recognize that there is no syn ACK coming back to syn. If you have anything to add, feel free to comment. I do appreciate your feedback and your tips and tricks you post in the comments. Thank you so much, Chris Evans, for sharing the PowerShell command I shared today. And I'll see you in the next video. Bye-bye.